Good afternoon, everyone. Thank you very much for coming to this talk. We're going to talk about security and improvements in Hadoop security. My name is Sanjay, and my colleague here, Chris. Both of us from Hortonworks. I've actually been part of the Hadoop team since 2007. I was the chief architect of Hadoop Core at Yahoo. In fact, I was part of the team that built Hadoop security. So Owen, myself, Kanzan, and a whole bunch of people, it took actually building the original Hadoop security with Kerberos and everything was approximately 10 person-years worth of work. And that entire team is right now at Hortonworks with exception of one guy, one of the original architects, Kanzan, who actually at that time left to go to IBM. So you're actually talking to people. And my colleague here, Chris, he's also a Hadoop committer. He's a member of technical staff at Hortonworks. He's an Apache Hadoop contributor. He's contributed to various parts of Apache Hadoop, including HDFS Eccles and other things that he's going to talk about today. And he's been a Hadoop user since 2010. Okay, so we're going to start the talk. I'll kind of do the first half of the talk, and Chris will kind of give you a lot of the details on the authorization and stuff like that. So I'm going to start quickly talk about models of deployment, secure, insecure, and give a little bit of background on Hadoop authentication. There's really nothing fundamentally new there, with the exception of maybe Knox, that has actually been there for a little while, but some of you may not know that. And then we're going to look at authorization, which is what Chris is going to cover. And look at a whole bunch of different components and what are the existing and improvements in authorization, and then a little bit about data protection and encryption, okay? And then we'll conclude. Okay, so really two main reasons for security in Hadoop. The first is that typically Hadoop clusters contain sensitive data. And as the Hadoop usage and usage models grow, and as different types of data, and Hadoop naturally the Hadoop cost of ownership becomes a lot better if, for example, you have a shared cluster. It also becomes much better for your business units if they don't have to go and work with their IT department to have their independent Hadoop cluster. So you really want a single Hadoop cluster. As soon as you're now mixing data that is sensitive, then somebody should access, somebody should not access. You cannot just say, these users have a private cluster. And so that model does not work, and therefore you kind of have to worry about authentication and authorization and everything, okay? And some of your data typically will be governed by requirements that you for legal requirement, legal reasons will have to follow. You know, whether it is, for example, data, you're in a financial organization, clearly it is pretty obvious, but if you're in the health industry, you have to make sure that you don't leak anybody's data, nobody else can see it. Okay, and so therefore there's a whole bunch of compliance reasons for HIPAA and that you do need to. And you may have other additional corporate security requirements that you relate to. So security is terribly, terribly important with big data, because generally big data is sensitive and important. Okay, so there are really three models of deployment. One is, of course, the insecure cluster. And there you typically, if you do an insecure cluster where you don't turn on the Kerberos and strong authentication, and that you will have some sort of a perimeter security, so not anybody can break into your cluster. But you will trust the code that runs, because it turns out in Hadoop, when you as a user submit a MapReduce job or a Hive query or something, there is often and sometimes user-submitted code that runs. While if you are doing a typical data center stuff on your production cluster, on your production servers, only pre-tested production code runs. No user just goes and submits a code into the system and says, run it on that server machine. But in Hadoop, that happens. Okay? In a Hive query, where typically you've done a SQL, you said, what code runs? Because that's all kind of a query, right? But you may have UDFs and file formats that pull in dynamically code that runs. So you may have to worry about that, and that's why you'll be careful about whether you want to run insecure. And what happens in an insecure cluster, that the Hadoop, the job submitter or the application that is accessing the Hadoop cluster, its credentials will be passed across, but on an advisory basis. So you know, it is not end-to-end authentication. In a secure cluster, there will be end-to-end authentication and can run arbitrary jobs, okay. And then there is something called perimeter security via Knox, okay. So kind of the 4 pillars are authentication, authorization, audit, and data protection. And in Hadoop, we use Active Directory and Kerberos. And for perimeter security, we've added, over the last year or so, something called Apache Knox, again an Apache open source project. We will not spend much time on audit in this talk, but just to give you a quick one, every service, Hadoop service, does do an audit log, and Knox and Access Secure, which I'll briefly mention at the end, provide central audit log support for that. Okay, we won't cover audit much more in this talk. So typically, in a Hadoop cluster, it supports single sign-on, which means users do not have to log in. Okay, so once you have signed on to your desktop, you should be okay. Or once you've signed on to a gateway node on which you have access to, you should be okay. And also, accounts do not have to be created for Hadoop. This was a very explicit thing that we plug into your external Active Directory user database. There's only one caveat here, which is that for MapReduce task isolation, you have to create user accounts on Unix accounts or Windows accounts. But that is really not for the base security. It is really there for isolation. And that is something that is going to go over with Linux containers. Okay? Hadoop supplements the Kerberos authentication with what we call delegation token. And the main reason I'll kind of cover in the next couple of slides, we have delegation token and block tokens. And I kind of cover why do we have them. In addition, Hadoop has trusted proxies. So for example, Uzi submits jobs on behalf of other people, and therefore it needs to submit a job on behalf of Joe, because Joe was the one who, but Uzi itself is connecting up to Hadoop as Uzi itself, and so Hadoop trusts the Uzi one. And then you have gateways like HDFS proxy, which may also be a trusted service, so they can act on behalf of others. Okay. Then there is the parameter security. One of the questions is that you have Kerberos security, why do you need this token stuff that Hadoop has? So, and the main reason is that in a standard client server model that Kerberos or most of the systems support, does not work, because what happens is that when you are logged in and you are writing a client from your logged in machine and accessing Hadoop, it works well. But if you're submitting a job, you've logged off after that, your job runs 3 hours later or half an hour later or something like that, that job, you no longer have the credentials that you logged in. And so that's where we actually use the tokens to carry forward your credentials in a sense. The other one is HDFS is a distributed file system, and the data nodes do not have any of the access control list. They're in the name node. So the name node checks authorization and then gives a capability token to the tasks to be used. So those are two things that are supplemented in Hadoop. And so, for example, you may have a third-party file system that's trying to say, I'll slip in it instead of HDFS and use the rest of the Hadoop stack. You could be careful about those systems, because do they actually provide these same sort of security that we do with delegation tokens? Because without that, it was not possible to do. Okay. I'm going to briefly touch on the Apache Knox and then pass it on to my colleague here. And so often what happens in a Hadoop cluster is that you often have a user who logs into a set of edge nodes, and then he runs Hadoop accesses Hadoop from the edge node. And it turns out the main motivation for that is typically one of two reasons. You don't want to install Hadoop on all your desktops, the version of Hadoop that's compliant. And that's one of the reasons why people do this. The other one is they want some sort of a perimeter security. So that's kind of what they do it for, those two reasons, okay? And what happens is that, this may become a bothersome for you to manage. And so this is where, and so you SSH into this node and then do Hadoop. And with Knox, this kind of goes away. And so what Knox gives you is a single access point. So you can actually sit from your desktop and use your REST API. You don't have to install anything and submit jobs or access your files, et cetera, in Hadoop. Okay? It uses REST, the Hadoop's internal REST, so it's a consolidation. And Knox is one of the features that also lets you deal with multiple Hadoop clusters. So you have multiple Hadoop clusters, you don't need multiple installations of Knox. Okay, it's a kind of a central place. It eliminates this SSH edge node, and it gives you kind of audit control and simple service authorization for REST. But it also gives you a single sign-on integration with other things like LDAP and SiteMinder and OAuth and SAML will be coming down the road. Okay, so it is something that is expanding the SSO thing. The only thing I want to mention on this slide, there are a bunch of REST APIs that Hadoop provides, and one of the challenges if you do use it without Knox is that you kind of need to know where is your data node, where is your name nodes, because that's where your HDFS service is, where is your resource manager, because that's where you should be submitting your yarn jobs, where is your Uzi, because that's your submitting, and so that configuration you need to do, Knox will do it for you because you'll only connect into Knox, okay? So that's one of the advantages that Knox gives you besides the perimeter security, okay? And so now we'll kind of go to authorization, and Chris will cover that part.
Thank you, Sanjay. Okay, so at this point we'll transition into talking about authorization. Authentication, we've already proven who you are. Now for authorization, what is it that you are actually allowed to do? And I'll be discussing some things that existed previously and some new features that have been added recently across the Hadoop ecosystem. I mentioned in my bio that prior to working at Hortonworks on Hadoop, I was a user of Hadoop for several years. And in that role, I was developing software, developing jobs. But in addition, I was responsible for some of the systems engineering functions. I was responsible for deployment, maintenance, and security was a part of that as well. I'm really excited by these new features because in many cases, these are things that directly came up as requirements in my experience. I'm always excited when I get to work on features that I would have used, for sure. So on this slide, we're giving a quick summary of things that I'm going to dive more deeply into in the next several slides. We're going to discuss HDFS permissions and how they have now evolved to include a concept of ACLs, access control lists. We're going to discuss Hive and traditionally how Hive authorization was controlled for Hive tables at the entire table level. And now how the model has evolved to allow different authorization rules on a per column level. Similarly for HBase, we had existing features for controlling authorization at the level of a namespace, a table, a column family, or a column. We'll discuss how those capabilities have now evolved to the individual row level or the individual cell level. First, we'll discuss HDFS ACLs. Prior to development of this feature, HDFS supported the traditional POSIX permission model. And this is very, very familiar to anyone. Every file is associated with an owner and a group. And then everyone else who is not an owner, not the owner, or not a member of that group is grouped into others. Then for these three classes of users, we define read, write, or execute permissions. Each class can have those permissions or not have them in any permutation. And this is definitely sufficient for a lot of security requirements. This is, as I said, familiar to anyone, and that's because it's used very, very widely. What we've seen is that this model can become insufficient in some use cases, particularly if you have unique requirements that don't exactly match the organizational hierarchy of your work environment. The solution to this problem is HDFS ACLs, and specifically what we did is to implement the POSIX ACL model in HDFS. The good news about that is if you've ever used that model, say on a Linux local file system, you already know exactly how this feature works. We strived during development very, very carefully to adhere to the model to the degree that we were actually executing our test cases against Linux in addition to HDFS and comparing them to make sure they match up. So if you're familiar with that model, this is going to be very familiar to you too. POSIX ACLs allow you to, in addition to the traditional POSIX file permissions, also define different rules for specific named users or specific named groups. It's a superset of POSIX file permissions. So to show this off, what I'd like to do is provide a motivating example of a typical file authorization requirement. Suppose we have a sales department. They have a sensitive file named sales data. And the rules for that file is that a single user, who we are calling Maya here, the department manager, is the only person who is allowed to modify that data. Additionally, there are other members of the sales department that need to read the data, and everyone else in the company should not be able to read the data or modify it or access it in any way. So this is something that's easily implemented with the existing POSIX file permission model. We have our file named sales data. Here we have the owner of the file set to Maya, our department manager. And for Maya, we've defined read-write permissions. We've also declared that the group of the file is sales, and all members of the sales department would be a member of this group. And we've stated that this group has read-only access. And then notice to the right of that in the permissions, everything else is crossed out, meaning others have no permissions at all. So that works fine, but then suppose our needs evolve. Suppose this department grows to a point where it's no longer feasible for a single user, for Maya, to make all the modifications required on the sales data. Suppose she needs to start delegating some of that work to some of her peers. Let's say we're now saying that there are 3 people, Maya, Diane, and Clark, who are allowed to make modifications. Additionally, let's say that we still have the requirement that everyone in sales needs to read, and everyone outside, everyone in the wider company should not see it. But there's this one exceptional group. There's executives who should be allowed to read the sales data. This is something that can't be expressed in file system, traditional POSIX file system permissions, because of the fact that we basically have one group to work with and one user to work with, and everyone else. So you have 3 variations to work with, and that's it. Once you have more than 3 variations, the solution becomes HDFS ACLs, which allow you to assign different permissions to specific named users and named groups. So looking at that, I mentioned that ACLs are a superset of permissions. So we still have that traditional permission model here. We have an owner, we have a group, we have others. But additionally, we can say group D can read, group F can read, and specific user Y also can read. You interact with this via some new tools that we've provided as part of HDFS. If you use the HDFS shell, these are the new commands setFacle and getFacle. And these are designed to work very similarly to Linux setFacle and getFacle. Here we see setFacle, and we're putting an ACL entry onto sales data that says group execs may read. If we then turn around and say getFacle on sales data, we have it returning back the information that is in that access control list. I apologize, this is not formatted correctly. The line endings should be making this easy to read for you. I corrected that beforehand, but it's back. So the way this should be read is the output of this command is showing you the owner in the group associated with the file. User : is the unnamed user. That's the same as what you're used to. Group : is also what you're used to as far as the group. But the really interesting thing here is the named group exec. Group execs has read access. There's a very easy visual indicator to know if you have an ACL defined on a file, which is just this little plus indicator appended to the output of ls when you look at the file. Again, similar to POSIX ACLs implemented on Linux. Additionally, there's the concept of a default ACL. And in this case, what happens is you can define a default ACL at a parent directory. During the creation of new child files or subdirectories in that directory, the default ACL is copied down. So here you see that by default, we have set a default of group execs, and that then propagates down to the new subdirectory /JAN. Additionally, the default of the new child also becomes the default of its parent, so that this will have a tendency to cascade the ACL down entire subtrees to meet that requirement. For best practices, we still recommend that you start by defining your authorization requirements using the traditional permissions model, then add onto that a smaller number of ACLs to deal with special cases. There are two reasons for this. One of them I forgot to include in the slide. The first reason is it's just simpler that way. There's less to understand if you're sticking to traditional file permission models. The second reason for that is that there is a cost associated with ACLs. There is some additional memory utilization required in the name node for that. Now we'll shift focus over to Hive and look at authorization of tables. The reason we need to discuss this separately is that HDFS itself doesn't have any notion of the table definition of the columns that are present in the table. So the way this has traditionally been managed is at a coarse-grained level using HDFS permissions to define authorization to Hive tables. And this is a consequence of the fact that Hive tables underneath in the implementation are stored as HDFS files broken down by partitions. The challenge, though, is more around column-level authorization. You may have requirements where you have a group of people that should have access to the table, but maybe there's a particular column that's sensitive. Someone in the keynote this morning mentioned anonymization. So you may have a situation where you have customer records and you want anyone in the company to be able to read that data, but you may have something like a social security number field, and that field should not be visible to the majority of users. That kind of thing has been challenging because authorization on tables has been coarse-grained until this point. So to solve this problem, what we have done is to allow the Hive server 2, to check authorization rules on individual columns at time of Hive query submission. The tables themselves are accessible by a special user, the Hive server 2 user. Additionally, there's a requirement that you should restrict registration of UDFs. The reason for this is that there is the potential for arbitrary code to be running in UDFs, and you wouldn't want to accidentally introduce some kind of side channel attack that would sidestep the authorization checks that are now performed in Hive server 2. Another thing mentioned in the keynote too is that SQL is something very, very important to users of Hadoop. One of the big next steps for customers is to ask what's going to be our SQL on Hadoop solution. So one of the very nice things about Hive column level authorization is that it's going to be very familiar to users of SQL. It's using traditional DDL permission management constructs to define the rules, grant and revoke. These ACLs, these rules, are then stored in the Hive metastore itself, along with additional Hive metadata. There's the open question here about PIG, which you may be thinking, even though we have controlled authorization to Hive columns, perhaps I have jobs outside of Hive that are consuming the same files, such as PIG or even straight up MapReduce. That's a legitimate question to be asking, and that's something we'll address in a slide in a couple slides here. This slide shows the new authorization architecture. We see the Hive beeline CLI submitting a Hive query through Hive server 2. And side by side with that, we see Hive authorization next-gen, which is storing the authorization rules in Hive's metastore before Hive server 2 is allowing job submission to consume those files in HDFS and the columns that are represented within that file. There's a side interaction illustrated here as well with Ambari. Ambari has the capability to turn on this new authorization feature in your deployed Hadoop clusters. Getting back to that open question about PIG or even straight up MapReduce, at that point, if you have a requirement where you're running in kind of a mixed mode where sometimes you're running Hive queries, sometimes you're running PIG or straight MapReduce, for those use cases, for the PIG jobs, for the straight MapReduce, it's back to table level authorization. It's back to coarse-grained authorization at that point. And this is because of the fact that HDFS itself, MapReduce itself, have no notion of the column definitions, which Hive Server 2 can enforce. Theoretically, and part of this as well is that in the case of PIG, in the case of MapReduce, there is no central point where it is convenient to enforce these authorization rules. There's no PIG server equivalent of Hive Server 2. There's not necessarily anything that precludes that architecture happening at some point in the future, but it's something that the current state is that job submission is driven client-side for those, so there isn't a central place to enforce the authorization rules. Here's a quick example of what this might look like. Suppose we have Hive tables representing a product management roadmap, and we have 3 roles to consider. There's an admin role, which is in control of membership in all other roles. There's a product management role, which has the rights to create and read all roadmap details. And there's an engineering role, which can read but not write. This is where, as I mentioned, things will start to look very, very familiar to anyone who has done any kind of DBA work, because it looks just like DDL that you're used to using in other database systems. First, we have the creation of the various roles. This is something done by the admin. And then we have granting of that role to various individual users. Here's the creation of the table in question. And then here we see specific rights granted to the various roles. We're saying that the PM role can do anything to the table, and the engineering role is limited to select. Moving on, the next thing I want to discuss is some new features in HBase. The HBase permissions model had already supported ACLs defined at a more coarse-grained level. Quick recap of the model. In HBase, there are namespaces, which are groupings of tables. Tables contain rows, which contain data populated for various columns. Columns are further grouped into column groups. And the capabilities you had before were to define ACLs at any of those containing layers, the namespace, the table, the column group, or the column. This can break down in some use cases, though, and the example I've given here is medical data. Suppose there is a table containing a row where each row represents a patient. And depending on the user performing the query, they should only have access to certain patients, but other patients' data should be invisible. And then along with that, even if you have access to a patient's medical data, perhaps you want to further anonymize on top of that. Perhaps you want to hide the social security number field from users. Whoops. Cell-level authorization augments the existing permissions model by allowing ACLs specified on individual cells. So the traditional permissions that you've had available to you in HBase, the create, read, write, admin, those can now be defined at the cell level. One interesting question then becomes order of evaluation. Do you evaluate the cell level ACLs first before all of the existing checks that we've always had, or do you evaluate them last? And it turns out that there are arguments either way, depending on the use case. So the individual operation can choose whether to evaluate the cell-level ACL first or last. And I give an example here related to what is the default behavior that you would find most desirable on an individual query basis. Additionally, there are now visibility labels. A visibility expression is something that can be stored as metadata on a cell. You can declare expressions such as, the example I gave here is financial or strategy or research, and the person is not a new hire. Each of those things, financial, strategy, research, new hire, those are arbitrary attributes that are associated to the user performing the query. The association of users to those attributes is something that is pluggable. By default, it's something that the application layer would pass along in API calls when you make the HBase query. And this is how you can achieve things like masking a social security number field from a particular audience of users. The visibility labels feature was inspired by similar features in Accumulo, and there's been some effort made to make the tooling around it, the CLI and such, very similar to what is in Accumulo, so that it's an easy transition for anyone who has used Accumulo. I'll quickly discuss some data protection features now, state of encryption. First, on-wire encryption. We support encryption between the HDFS client and the data node. We support a configurable encryption cipher strength, depending on your requirements. Hive Server 2, similarly, there is encryption provided via SASL, simple authentication and security layer, which is a standard for protecting application-level protocols. This is something that is theoretically applicable to any TCP protocol at the application layer, and it's something that we've used across a lot of Hadoop. The shuffle, there's a network interaction between nodes during the map to reduce shuffle. That's protected via HTTPS. It's capable of mutual authentication so that the shuffle client knows that it's talking to a valid shuffle server, and likewise, the shuffle server knows that the client is legitimate. REST protocols that have been mentioned throughout the talk also support SSL. In some cases, there are also regulatory requirements that isn't sufficient, that data at rest on disk must not be in plain text form. And there are some new developments that are happening right now in the Apache community in that area. I've left reference to 2 relevant Apache JIRAs here that contain more of the details on that. And at this point, I'll hand it back to Sanjay. One of the things that I've found interesting in preparing these slides is that I mentioned having done some sysadmin work on this, and one of the things I find interesting is that you need to touch a lot of different tools if you're using multiple parts of the Hadoop stack to control authorization rules. And now we're going to talk about something that will hopefully make that a little bit easier. Thank you.
Okay, thanks, Chris. So we're going to talk about a company called Access Secure a little bit, and they were actually with us in many customers. They kind of solved a number of problems that were missing in the stack, and we liked them enough, and our customers liked them enough that we just decided to acquire them. I'm going to briefly just touch on them for a couple of minutes, and then there's actually more details in Sean Connolly's keynote tomorrow, Wednesday morning. Okay, so basically the main thing about Access Secure is they provide completely centralized security administration. So they kind of, everywhere where I put on kind of the XA thing is where they add value. So they provide authorization from a central place and additional authorization models. And they also provide centralized audit management in looking at who's accessing from a single central location and being able to search that. So the authentication works as is. Okay, in HDFS, Hive, and this, they add much more finer grain authorizations. In fact, they added ACLs before HDFS had ACLs, and they do RBAC, role-based access control. into Hive, HBase, and HDFS. And they do kind of centralized audit reporting and policy-based access control. Okay, and they have some stuff that's upcoming in this. And so typically, one of the next questions that we often get asked is this going to be open source, or is this going to be a way that Hortonworks is going to lock you guys in? No, it will be open source, and it'll be open sourced in a way that it'll not lock you in. It'll not just be an Apache license or some other license where you are still forced to get the latest one from Hortonworks, but there are older versions available in open source on a Git repository somewhere. No, it'll be a full-fledged Apache project where you'll be able to participate in it as a developer on equal basis with us, and as a user also. So there'll be no lock-in. If someday you're not happy with us and you happen to be using these features, you could go to somebody else. So true, this is what we do for every single project, everything we do. Everything is Apache open source project, okay? So you'll see some more details about that, and you can see our press and stuff. So this just happened a couple of weeks ago, okay? So it's traditionally very strong authentication that we have supplemented with authorization, and there have been a whole bunch of improvements that on authorization that Chris has talked about. So I'm going to kind of conclude here and give you guys a chance to ask the questions. I've got about only 4 minutes left. Thank you very much. Questions?
Any questions?
Is there a tie-in between the OS ACLs and the HDFS ACLs? Are they mapped? Is there any problem with that?
Are the HDFS ACLs and the OS ACLs?
Do they conflict? Do they work together? Is there any?
No, so, okay, so there are no OS ACLs that are in the file system that are visible. So Hadoop has POSIX-like permissions, but they are on Hadoop file system. So the underlying block files, their permissions are usually set to be owned by HDFS. HDFS's own permissions used to be POSIX ACLs, POSIX permissions, excuse me. And now they've been supplemented. So both of them are used in the same way in Linux where you have both permissions and ACLs, and they'll work the same way. So they both work in conjunction. Okay, so for example, if you have permission you think of the ACL as being the sum of the owner, the user, the other, and all the ACL permissions together. Okay, so they all are checked, and you only allowed access if you allowed access. So really, then there are no conflicts, just like you have in a traditional Linux. Other questions?
Are you?
Now you have to use Hadoop too, yes. So ACLs, you have to use Hadoop too. You had a question?
You have one back here.
Nice.
So the question was on HDFS cell level and what is the overhead. Chris, do you know the answer to this one? On HBase, sorry, excuse me, sorry, on HBase.
So I don't have anything like a benchmark to give you as an answer per se, but it is correct to be thinking about that, and I think that's what motivates the fact that the feature is there for you to choose evaluation of the cell level ACL upfront before table level, before namespace level, et cetera. Or you can choose to do it after those existing checks. So if you're using the feature in a model where most of your permissions are controlled at the table level, and many of the decisions will be granted or rejected at that level, and you just have a much smaller set of exceptions defined at the cell level, then in that case, it would probably make sense to evaluate late. If you're heavily using cell level ACLs more so than at the table level, then earlier evaluation of the cell level is probably going to make sense. Actually, just a moment, can we make sure that the people at the mic?
It will be your answer afterwards.
We'll bounce back.
Probably the last question or close to last. Go ahead.
I mean, the entitlements on data exists on multiple systems of record. So I don't want to define that again if I've already defined it in the system of record. Are you guys working on import functionality to read from system of record into the Hadoop cluster?
You understand? I'm not sure if I understood the question.
So if I understand correctly, there's, this sounds like a question of integration, is that right?
Yeah, so simple example, you've got an Oracle database, you're importing into Hadoop, you're going to use Hadoop, but you've already defined your security in Oracle, Teradata, DB2, whatever. So that happens all the time. I don't want to have to redefine my whole security model.
Yeah. I think the best answer in that area that we can offer right now is, there was the mention of XA Secure. I recommend looking into that. That may be an answer to your question. And there's more info in, is it in tomorrow's keynote, Sanjay? Yeah.
Yeah. But we can chat in more detail afterwards. I think we are 9 seconds, so we are kind of done. And Chris will be down here and then back outside. A few questions. Sorry, we kind of ran out of time.
That is the end of our Q&A. So thank everyone for coming. Let's
Thanks,
give them a
everyone.
round of applause.